Alright, hey everyone. Today we're looking at something called the lawnmower problem. Okay, and the idea being that I need some of my yard mowed, and there are three people to do it. There's person A who'll do it. The travel call out fee, I guess, is $10, and then once they've done that, they'll do it for $10 per hour. So I've got to pay them $10 to come here, and then $10 per hour after that. Person B will do it for $5 call out, so they'll travel to my place for $5, and then after that it's $15 per hour. And then person C is not going to charge me at all for traveling to my location, but will charge me $20 per hour. So the idea being, we've got to figure out which person is best for which job, right? Or for what length of time. So I've already written up some tables underneath that I can fill in to give me a bit more information and hopefully help me make a better decision about this. So I'm going to fill those in. So person A, now you notice with the first table I wrote them as hours X and cost Y, but because you get the idea, for the rest of them they're just going to be X and Y. So for hours X and cost Y, we have for person A, their call out fee is $10 and then it's $10 per hour, which means if they haven't done any work at all, just the travelling fee, so no hours worked, is just $10. So their first value, I guess, is $10 regardless of whether they've done any work, just for that travel. After that, they've worked an hour, so it's an additional $10 on top of the $10 that they've already got. They work 2 hours, they get $20 on top of the $10 that they've got. And as you can see, this pattern is pretty obvious. We don't have to sit there and go through all that because it's pretty straightforward. Now let's look at person B. Person B, they do no hours work. The $5 is what they get. I've written this box a little bit too small, so I'm just going to write underneath 20 for doing 1 hour because it's the $5 plus the $15 that they get per hour. So then after 2 hours it's $35. An additional 15 for 3 hours makes it $50. $65 and finally $80. Alright? So that's where we're at. So it starts at $5, it goes up by 15 every time. Now the last person, I have stupidly left off the 0 coordinate, so I'm just going to chuck that on the end here. Whoops. Alright. So the last person, if they do no work, they get no money. Right? That's purely based off how many hours they work. So 1 hour is $20, 2 hours is $40, 3 hours is $60, 4 hours is $80, and 5 hours is $100. Right? So now the question arises: who's the best to hire if your work is only going to take 1 hour? We have a look. 1 hour here is $20. 1 hour here is $20. 1 hour here is $20. So our answer is they're all the same. They're the same. Right? Who's the best to hire for 3 hours work? Well, we have $40, $50, or $60. So person A is the best here. What about for 5 hours work? We've got 60, 80, and 100. It's person A again. Alright. We go, okay, well, what about half an hour of work? Well, that one's a little bit harder. We can't figure that out just from our table. We can either use the equation that we come up with or the graph. Right? So we're going to do both of those things and have a think about I guess which is best for that half hour, so we can answer that properly. In terms of the equations, remember we have y equals mx plus c, and m is it's what's called our dependent variable, which means it's affected by the change in whatever x is. So in this case, as hours goes up, whatever I guess value is multiplied by the number of hours, or is changed by the number of hours, is our dependent variable. Our independent variable is the one that, regardless of how many hours you work, stays the same. So with that in mind, let's write in our equations. So for A, we have $10 call out and $10 per hour. So if y equals, if it's $10 per hour, then that's our dependent variable. So y equals $10 times x, which is our number of hours, plus $10. So that's good. All right, nice and simple. Let's have a look at B. Again, our call out is the independent variable and our per hour is the dependent variable. So we have y equals 15 times the number of hours, because 15 per hour, plus that $5 call out. Right? Keep in mind, if that value is 0, they still get charged the $5, just like in our table. And the last one, we have y equals 20x, because it's $20 per hour, plus 0. Right? Because there is no call out. Now, plussing 0 can be somewhat pointless, so I can just scribble that out if I want. It makes no difference, because I'm plussing nothing. It's up to you if you want to leave it there or not. Okay, so that's our equation. Why don't we plot these and then get an idea of which one is best. So I'm just going to scoot this up a smidge, just so you might not be able to see the graph from there. Alright, this is our graph. I might have to add on a couple more values here, because I think they go up to 100. 95, 100. Alright, so we've gone up to 100 there. Now what we're going to do is we're going to plot each of these individual people and then have a look at which one is best when, and we're going to analyze this graph. So let's do the first one. So person A, we're going to do in red. So when they've worked 0 hours, they're at $10. They basically start at $10. Right? That's person A, starts at $10. After an hour, they get $20. After another hour, they get $30. After 3 hours, they get $40. After 4 hours, they get $50. After 5 hours, they get $60. After 6 hours, they would get $70 if I were to continue that pattern on. Alright? So that's that. And you're going to use a ruler to draw your line, but I do not have one, so I'm being a little bit of a hypocrite here. Alright, you draw that line through, and that's going to go on forever. And this is person A. Person A, or you can write y equals 10x plus 10. Right? So we're labeling our line 2. Maybe make it a little bit straighter through there. Alright? So that's person A. Let's have a look at person B's line, which we'll do in, I will do that in blue. So person B, I know you can't see the coordinates, but they start off at 5, and then they go up by 15 every single hour. So after 1 hour, they're at 20 as well. After 2 hours, they're at 35. After 3 hours, they're at 50. After 4 hours, we're at 65. After 5 hours, we're at 80, is up here. Right? And if we were to do 6 hours, we're going to do an extra one, we would be at 95, which is up here. Right? So again, I'm going to draw a line through there. Again, hopefully you would have a ruler to do this. Oh. Let's just pretend that that's straight. Right? Nice straight line. This is person B, which is y equals 15x plus 5. Okay. Now person C, who I'll do in green, has no call out fees, so they start at 0 in terms of cost. After 0 hours, they get $0. After 1 hour, they get $20, and I'm sure you can guess. After 2 hours, they get $40. 3 hours, they get $60. To 4 hours, they get $80. After 5 hours, they get $100, and I can't even do 6. 6 would be up here somewhere, right? So I'm just going to leave that for now, and I'm going to draw my line through here. That's my line there, and that is person C. Y equals 20x. I don't need to put the plus 0 because there's no point. So y equals 20x. So now I get a look at how much each person will cost over time. So the question is, after half an hour, which one will be the cheapest? So if I go to about here, I look at which cost is the lowest. Right, after half an hour, the answer is person C. So that helps me answer what would normally be a difficult question. Phew, sorry. But yeah, that's basically it. All right. So we just looked at how much each of those people will cost to provide their service. We graphed it and we look at which one was the lowest at which point in time, and that helps us decide. Right? That helps us decide which person is the best to use. Now, the toughest question to answer would have been, after 1 hour, who do you use? Because they're all the same, right? Which is what we had at the top there. Yeah, right. Hopefully you found this interesting, and it gives you some background to help you do the work today. Have a great day.